Hello guys, today we're going to do a small review of quadratic functions and equations. Now remember, quadratics have a parabola shape, could be inverted. Please remember your transformations, up, down, left, right, horizontal and vertical, stretching and shrinking, and reflections across the x and across the y. We're not going to go over that today, but we will be seeing that later on. Today we're going to focus on basics, just graphing equations, quadratic equations, when they give them to us in standard form. Now remember, we can be given quadratics in vertex form. We can be given quadratics in standard form. And we can also be given quadratics in intercept form. Each one has its own benefits and its own problems. For today, we're going to be focusing on standard form. So now please remember that when we're working with all the formulas in standard form, we use the following guide. The letter, or one of the number, stuck to the variable of second degree is pretty much going to be a. If there is no number there, you have to know that a is 1. 1 times x squared. The coefficient of the variable of first degree is going to be b, always. And the constant is always going to be c. The number with no variable, always going to be c. Now, let's say, for example 1 in the book, they're telling us graphing quadratic functions using tables. Now, normally, we would not graph using tables. It's very inefficient. It's probably easier to convert any standard form, factor it, turn it into intercept form, and then just graph using the intercepts. But again, today we're going to learn how to graph quadratics using a table. Now, let's say, for example, I'm given the one in your book, example 2. I'm told 2x squared minus 8x plus 4. In order to graph any function, not just a quadratic, you're going to do an input-output table. X's are inputs, and the answer you get back is the output. Let's just change this for y. Might help you guys a little bit. So I'm going to have x and y. Now let's begin. For example, when I use x equals 0, I'm going to put my x 0 here. I'm going to switch all these variables for 0, and then use PEMDAS in order to do these operations. 0 squared is 0 times 2 is 0, negative 8 times 0 is 0, and I end up with an answer of 4. So when my x value is 0, my output will be 4. When my input is 0, the answer I get back, or output, will be 4. I use another number. Let's go with 1. Now let's switch this variable for 1 and this variable for 1. All x's do have to have the exact same number. You cannot put a 1 here and a 0 in the other x. No, same letters are substituted by the exact same values. Now again, remember, PEMDAS. It is not 2 times 1, 2 squared, 4. That is absolutely incorrect. PEMDAS, exponent first. 1 squared 1 times 2, 2. Here I have negative 8 plus 4. I add everything and I'm left with negative 8 plus 6, which is negative 2. So when my input is 1, my output is negative 2. Let's continue. Let's use the number 2. And again, you can see why this is very inefficient. I never do a table in real life. I just factor. There are other ways we can graph. We'll see vertex form or intercept form. But again, we're using a table in standard form. 2 squared, 4 times 2, 8, minus 16, plus 4. We add these is 12, minus 16, negative 4. Let me grab my eraser. Doesn't want to work again either. Let's input 3. 3 squared, 9 times 2, 18. 3 times negative 8, negative 24, plus 4. I got 22 minus 24, negative 2. And then let's do, over here on this side, the last number, 4. And again, remember, I will tell you some tricks to see what numbers you input. In case the parabola has been shifted left or right, these values should change. We'll see why later, but these numbers are okay for now. So I put a 4 here and a 4 here. 16 times 2 is 32. Negative 8 times 4 is negative 32 plus 4. These cancel out. And when I do an input of 4, I get an output of 4. Now there's a couple of things we can see from this table of values. There is a central value, negative 4, and then as I go 1 unit to the right and 1 unit to the left, I go up to negative 2, and then a further unit to the left and a further unit to the right, I go up to 4 and 4. So pretty much, since it is symmetrical, the exact same distance on one side gives you the exact same value as the other side, you can easily tell that the negative 4 is the midway point of the parabola. Now that is known as the axis of symmetry. It's a perfectly vertical line that reflects the same thing on one side as the other. And again, this is your x value of negative 4. When you go 1 unit to the right, I go up to negative 2, and I go 1 unit to the left, negative 2. 1 more unit to the right, I go up to 4. 1 more unit to the right, to the left, I go up to 4. So again, you can tell from looking at these numbers that that is the axis of symmetry. You'll see later that there are quicker ways to find this, and we're going to learn that a little bit later down today. So for right now, I realized that this table can actually help me graph the parabola perfectly. Now remember, I said x is the input, y is the output. But if you remember the coordinate plane, you have ordered pairs, x's and y's. X is the x-axis and y would be the y-axis. All you have to do is graph each of these pairs in the coordinate plane, and it will pretty much give you the graph of the parabola. Now, again, I'm sorry I don't have a ruler here, but let's say this is 0, 4, more or less here, 1, negative 2, more or less here, 2, negative 4, more or less here, 3, negative 2, and 4, 4. I have all these dots. If I join them from left to right, you can see that they form more or less a parabola. Now, please always do these graphs using graphing paper. It's a lot easier and quicker, and it looks more pretty, but that gives you a very basic manner on just how to graph any equation using an input-output table. Now, we talked about the axis of symmetry, which is the line that reflects the parabola equally on both sides. Let's also focus on the vertex. The vertex is either going to be the lowest point if the parabola opens upward, or the highest point if the parabola opens downward. Whether a parabola opens up or down, there's only one thing you have to look at, and it's the sign of the leading term. For example, this parabola, since the leading term sign is positive, opens up. If you flip it to negative, it opens down. Now, know that in the exams that you might get, these points might be called either minimum or maximum, the highest or lowest point, but usually they're referred to as maximums and minimums. Parabolas that open upward have a minimum. Think of a pool or a valley, the lowest point, or a hole, the lowest point, it opens upward. And parabolas that open downward have a maximum. Think like a mountain or a small hill. You go up, you're at the highest point, that's the maximum. So now that we're done with tables, let's start looking at graphing using what I think is a somewhat better method, but still very slow, using the axis of symmetry, the y-intercept, and the vertex. Also, this is example 2. So let's say we're given the following quadratic function. 2x minus 3. Now, instead of doing a table, try this. It's better. There's a little bit more, slightly more advanced concepts, but it's a lot faster and there's less chances that you mess up because you don't have to do as many operations. Now, step 1 pretty much is determining A, B, and C. And please do yourself a favor and write them down, because many students forget the signs associated to these values and they do the operations without taking into consideration the signs, and that's going to mess up your math. So just write A, B, and C, then you look at your A. Well, in this case it's 1. You look at your B, positive 2, and you look at your C, negative 3. Remember, A, B, and C only refers to the numbers, not the variables or letters. So you only focus on the numbers. 1, 2, and 3. A, B, and C. The sign is associated. You have to always remember the sign. Now, step 2, we have to find the axis of symmetry. And we use this very simple formula. Negative B over 2A. And again, many students mess up due to this negative. Sometimes B is a negative number and then they just copy it in there. In order to avoid this confusion, I always ask my students to do the following. Whenever you have a variable, you open a parenthesis. So you copy everything as is, but you leave an open parenthesis. And inside these parentheses, you're gonna plug in the corresponding values. Here, I have B. B is the number 2. Here, I have A. A is the number 1. After you plug your numbers into your parentheses, then you multiply. And believe me, this decreases the amount of errors if you do it this way. Negative times 2, negative 2. 2 times 1, 2. When I divide this, I get that my axis of symmetry is negative 1. However, I'm not done yet, because again, the axis of symmetry only tells me the line where the parabola is reflected across. But it doesn't tell me if it's reflected here, if it's reflected down here, if it's reflected here. So it doesn't tell me the point where it reflects across. It just tells me the line. Now, in order to find the point, that's called the vertex, all you have to do is input the axis of symmetry into the basic equation as an input. So I'm gonna have, and again, I also recommend you guys do the parentheses thing when you're inputting variables. It's gonna help you with the signs. Please believe me. I put a negative 1 in here, I put a negative 1 in here. Because that negative 1 is the axis of symmetry. When you plug in the axis of symmetry, it's gonna give you a value, that value together with the axis of symmetry will tell you where the vertex is at. So now I have negative 1 squared is 1, 2 times negative 1 is negative 2 and minus 3. When I add these numbers, I get 1 minus 5 or negative 4. Now together, we're gonna form a coordinate pair. Negative 1, which was your input, is gonna be your x value, and negative 4, which was the answer of plugging this in here, will be your y value. And again, always keep a very different idea of what inputs and outputs. Inputs are x's, answers are outputs. Together, you can graph them in any coordinate, and that's perfect. So, what do we do now? I know that my axis of symmetry, the line that perfectly reflects the parabola, the axis of symmetry, is at x equals negative 1. I'm sorry, I'm trying my best. Even though it's not a straight line, you get the idea. That should be a straight line. Now I'm gonna label the -4 along this line. -4, let's say it's here, would be my vertex. So right now I only have a single point of my parabola. What other information can I see from the information, or what else can I gather from the information I was given? That the C is always going to be your y-intercept. Your y-intercept. When these x values are 0, this number will tell you where the parabola crosses your y-axis. So if this is -4, let's say that your y-intercept is -3 down here. Now you know that this axis of symmetry reflects the parabola identically on the other side. So all you have to do is reflect this distance on this side. So it's more or less there. If you need to draw further than this, I know this value is 0, so I can use the number 1. Let's do that and see what happens. When I plug in 1 here, I get 1 squared is 1, 2 times 1 is 2, and -3. When I add this, I get 0. So at the value of 1, my parabola will be 0. I do not have to calculate on this side. I can just reflect across. Boom, and you're done. That's how you graph parabolas using the axis of symmetry, the vertex, and the y-intercept. And that is how I recommend you graph the parabola if you are given standard form. Do not do a table. Very inefficient, not very helpful. Pretty much that's it for today. Tomorrow we're gonna go a little bit further into factoring and solving, completing the square, quadratic formula, a couple of other things. So that's it for today. Good job.